Magnets. Introduction. Magnetism finds numerous applications in everyday life as well as scientific research. Our Earth itself behaves like a huge magnet. We shall get ourselves attracted to the magnets. The word magnet comes from Magnesia, a district in Asia Minor where the iron ore magnetite was found to attract iron. This property is known as magnetism, and bodies having this property are called magnets. What are magnets? Any substance which possesses the following two properties is called a magnet. It attracts small pieces of iron towards itself. It always comes to rest in the north-south direction when suspended freely. Natural and artificial magnets. Lodestone and magnetites are natural magnets because they are found in nature. Natural magnets have a low magnetic power. Moreover, such magnets are not found at every place. So, artificial magnets are prepared by man to be used at any time and at any place. These magnets are much stronger than lodestone. Artificial magnets are made in many shapes. They may be rods, flat bars, U-shaped, or like a horseshoe. Magnetic and non-magnetic substances. Collect a number of small objects such as brass screw, copper wire, iron nail, sewing needle, paper clip, eraser, pencil, shaving blade, plastic scale, glass lens, postcard, safety pin, spoon, cork, rubber band, toothbrush, etc. Use a magnet and identify which of these substances are magnetic and which are non-magnetic in nature. Parts of a bar magnet. A bar magnet has the following parts. Magnetic poles. The points N and S at the two ends of magnet are called the north and south poles of a magnet. Magnetic north pole. The point N at the end of a freely suspended bar magnet pointing towards the north is the magnetic north pole. Magnetic south pole. The point S at the end of a freely suspended bar magnet pointing towards the south is the magnetic south pole. Magnetic axis. It is an imaginary line, XY, passing through the north and south poles of a bar magnet. Magnetic equator. It is an imaginary vertical line, PQ, dividing the bar magnet into two equal parts. Effective length. It is the distance between the magnetic north pole and magnetic south pole. Length of a magnet. It is the distance N or S between the center of the magnet and one pole. Properties of magnets. Poles of a magnet. The two ends of a magnet where the magnetic force is greatest are called the poles of the magnet. Each magnet has two poles. Magnetic attraction. Spread out some iron fillings over the sheet of paper. Now, move a bar magnet in the fillings, taking care that all parts of the magnet touch the fillings. Pick up the magnet and observe how the iron fillings are distributed all over the magnet. You will notice that most of the iron fillings cling near the ends of the magnet, while there are a few iron fillings near the middle. Repeat the experiment with a horseshoe magnet. You will find that all magnets have maximum attractive property of magnets. Directional property. The end of the magnet that points towards the north is called the north pole, N pole, and the other end of the magnet pointing towards the south is called the south pole, S pole. A magnet always points in the north-south direction when suspended freely. Pole attraction and repulsion. Take two bar magnets. Suspend one magnet with a piece of thread. It will come to rest in the north-south direction. Hold the other magnet in your hand and bring its north pole near the north pole of the suspended magnet, as shown in figure. What do you see? You will find that the north pole of the suspended magnet is repelled. That is, north pole moves away. Now bring the south pole of the magnet in the hand near the north pole of the suspended magnet. You will find that the north pole of the suspended magnet will be attracted towards the south pole of the other magnet. That is, north pole of suspended magnet will come close to south pole of magnet in hand. We therefore conclude from this activity that like poles repel and unlike poles attract each other. Magnetic poles always exist in pairs. If a bar magnet is broken into two pieces, you will see that each piece behaves as a whole magnet. This shows that new poles are formed at the broken ends as shown in figure. If these pieces are broken again, each smaller piece still remains a whole magnet with two opposite poles. Even a very small piece of a magnet is a whole magnet. Thus, we see that even the smallest piece of a magnet has north and south poles, and we cannot separate the two poles. We therefore conclude that the poles of a magnet cannot be separated. Magnetic poles always exist in pairs. Magnetic induction. The phenomenon by which an ordinary piece of iron acquires magnetic properties temporarily due to the presence of another magnet near it is called magnetic induction. Making a magnet. There are two methods of making a magnet: single touch method and electrical method. Single touch method. The iron bar AB, which is to be magnetized, is kept on the table top. A strong bar magnet is kept on the table top. A strong bar magnet is kept nearly vertical with its pole touching one end of the iron bar. The magnet is moved along the iron bar to the other end. It is then raised and brought back to the starting position. The process is repeated 30 to 40 times, moving the magnet always in the same direction. The bar is then turned upside down and treated similarly. The bar is tested by bringing it near some iron fillings. If the bar attracts the iron fillings, it shows that it has been magnetized. Thus the iron bar becomes a magnet. The starting point acquires the same pole as the pole of the magnet which was moved over it. Electrical method. The soft iron bar, which is to be magnetized, is kept inside a long coil of an insulated wire. When a powerful current of electricity is passed through the coil, the bar gets magnetized. It is called an electromagnet. This phenomenon is called electromagnetism. If a steel bar is used, it becomes a permanent magnet. But on the other hand, when a soft iron bar is used, it becomes a very strong temporary magnet. The soft iron bar remains magnetized till the current is flowing through it. As soon as the current is switched off, it loses its magnetism. The strength of the magnet can be increased by increasing the current flowing through the wire coil across the iron bar. Magnetic keepers are pieces of soft iron which are placed between opposite poles of pairs of bar magnet or horseshoe magnet. Magnetic compass. A magnetic compass is a simple device which has a magnetic needle free to rotate on a pivot at the center of a round box as shown in figure. It is used by sailors and navigators to know the northern, southern, eastern and western directions. In the compass, the needle which is free to rotate rests in the north-south direction.